Hi everyone, welcome back to topic 7. Today we're going to look at solving quadratics where we have a number in front of our x squared. Alright, so hopefully you guys understood and were able to follow through with topic 7. With this, we're just adding this number out in front. Now it changes things slightly. I want to walk through it. There's a couple different ways that you can do this, depending on what you guys have seen in the past. Maybe you have seen this, maybe you haven't. There's 3 or 4 different techniques that I've seen. I'm going to show you one that I think works. And if you have any questions about it, let me know. You can always look up a couple different ways. But this is one that I think works pretty handy. Now, what you're going to do is you're going to treat this very similar to the last problem. Now, we're going to start by taking and setting it up as binomials. You take your first term now, and this is where things are a little different. We're going to take our 7x, and we're going to put 7x in both of these. Now, I know that if I go back and FOIL these, 7x and 7x does not equal 7x squared. And you'll see at the end what actually does happen. Now we take this first number and our last number, so our a and our c, and we're going to multiply those together. So if you think a times c, you get 7 times 4, which is 28. That's the number I'm going to use to get my 2 different factors here. Okay, so I want 2 things that multiply to 28 and add up to 29, and that's going to be 1 and 28. And they're both going to have the plus signs. All right, and that's found out the same way as back in topic 6. Now, once you get to this point, I want to look at these and see if they have any greatest common factors. Now, these ones don't, so it stays as 7x plus 1. But these ones do. Both 7 and 28 have a 7 that goes into it, so you can reduce that down to x plus 4. And now if you take your first 2 terms, 7x times x, and you work with FOIL, that gives you that 7x squared. And if you were to combine all these together using FOIL, you would end up back here, and so this is your final answer. Okay, so we take this first term, we break it down into each of these. You're going to multiply across to get you this product, and then look for the factors there that combine to give you that 29. Okay, let's try the second one. So to set this up, we start here. You've got a 3x, a 3x. We multiply our a times our c, and that gives us 60. So we're looking for 2 things that multiply to 60, add up to 17. Now, it may not come to you right away. You can go through and look at your factors. So 1 and 60, 2 and 30, 3 and 20, 4 and 15, 5 and 12, 6 and 10. Those are all the lists of factors of 60. And if you're looking for the ones that multiply to 60 and add up to 17, you've got 5 and 12. But because this one's negative, they're going to both be negative. So you've got a negative 5 and a negative 12. And now you're combining down, looking for those common factors. Okay, there isn't one here, but these are both divisible by 3. So you take a 3 out of both using division. Oops, mistake there. And 12 divided by 3 is 4. That is now your common factors, and this is done. Okay, so there's that. Hopefully that's starting to make a little bit of sense. Let's move on to C and D. Now if you notice in C, you have 6, 22, and 8. Now there is a common factor there of 2. So I'm actually going to divide out and factor out that 2. Now we looked at that a few topics ago. The greatest common factor can come out. And when I do that, I think division. So I end up with 3x squared plus 11x minus 4. And now we factor this down. So I put my 2 binomials there. I've got a 3x and a 3x. I multiply a and c. That gives me 12. So 2 things that multiply to 12 have a difference of 11 because of the minus is going to be a positive 12 and a negative 1. Okay, so multiply to 12 and have a difference of positive 11. Now looking here, these have a common factor of 3, so I'm going to divide that 3 out. That gives me x plus 4. Here, these have no common factor, so I got 3x minus 1. And now I'm back to my final answer. And there you go. Okay, final one together. We go through this one. Now, there's nothing in common here, so I'm going to set this up again. I've got 2n, 2n. I multiply across, so 2 times 1 is 2. Now, the only factors of 2 are 2 and 1, so I know that they're going to be 2 and 1 that go into here. But I want a negative, so I'm going to have a negative 2 and a positive 1. And when I combine those, that gives me that negative 1 that I'm looking for. And now we look for the common factors. So I have 2 and 2. That is going to eliminate a 2 out. This one, 2 and the 1, no common factors. And I leave it just like that. And here is your final solution. Okay, I want you guys to pause the video. give E and F a try, and we'll come back and look at them in a second. All right, hopefully you guys had some time to work through those. Let's see what you did. So we break these down. I've got the 2x. I multiply across, get an 18. So we're looking for two things that multiply to 18, have a difference of 3. Well, that's going to be 6 and 3. I need a negative there, so I'm going to have opposite signs. So negative 6 and a positive 3. And now we look for those common factors. Well, here, both of those can be divided by 2. So I divide that 2 out, I get x minus 3. That ends up staying the way that it is, and there's your final answer. And then finally on F, 4, 22, and 10, those all have a 2 in common. So I can pull that 2 out. I get 2x squared plus 11x plus 5. All right, now we start breaking this down. My two factors, a 2x, a 2x. This times this gives me a 10. So two things that multiply to 10, add up to 11, are going to be they're going to be 10 and 1. So I take my 10, put it here, put my 1 here. I have pluses in both of those. And now I break those down. So I've got a 2 here. A 2 divides out of both of those, so you got an x plus 5. Okay, nothing comes out of there. You end up with 2x plus 1. And there is your final answer. And for all of these, you could FOIL them back together to prove that they work. All right, now, when can we use this? Well, there's a lot of applications with solving. And so we want to solve these last two. Okay, so in these last two, notice they are set equal to 0. At least this one is. So that's using that zero product property from the last two topics. Okay, so we're going to try and set this up and solve it. So we've got a 2x, a 2x. I'm going to multiply 2 and 18. That gives you a 36. So we need two things multiply to 36, have a difference of 9. Now this is a bigger number, so if you need to make your list, go ahead and do so. So you've got 1 and 36, 2 and 18, 3 and 12, 4 and 9, 6 and 6. We need the two that have the difference of 9, which are going to be 3 and 12. And that gives this a positive, that a negative. Okay, and this is all equal to 0. Okay, so now looking for common factors. That doesn't have one. This has a 2 in common. So I pull that out, I get that, and it's still equal to 0. Now just like last section, I take each of these, set them equal to 0, and solve. So 2x minus 3 equals 0. X plus 6 equals 0. And then I solve. So I add 3. That gives me 2x equals 3. Divide by 2. And x equals 3 halves. Sorry I'm overlapping here. But on this one I subtract 6. Those cancel. My second answer would be 0 minus 6, which is negative 6. And there are your two solutions. Okay, and like always, you can substitute them back in, make sure they work. All right, final one for this section. I want to set this equal to 0. You guys saw that in topic number 6. So I move my 15 over. So I've got 2x squared minus 13x plus 15 equals 0. So now that it's set equals 0, I try and factor. So you got 2x, multiply here and here. That'll give you 30. So two things multiply to 30, add up to 13. You can create your list. Those turn out to be 10 and 3. And in both cases, I have to have a minus. And now solve them out. So common factor there is a 2. That gives you x minus 5. No common factors there. So you have 2x minus 3. And then set both of them equal to 0 and solve. So x minus 5 equals 0. 2x minus 3 equals 0, and solve them out. So I solve this, I add 5 to both sides, I get x equals 5. This one, I add 3, divide by 2, very similar to what we did up above. You end up with a positive 3 halves, and there's your solutions. Okay, hopefully that cleared some things up. If you need any help, contact me online, and good luck with your assignment.